Hello everybody. Today I want to show you how to draw a Bohr model. So you should now at this point be familiar with how to go between these three things. This up here at the top is the name of the isotope, the atom that we're doing. That therefore transfers into the symbol. So we've got the letters and we've got the mass number of 20 and the atomic number of 10. And that then tells us that it has 10 protons because of the 10, 10 neutrons because 20 minus 10 is 10, and then 10 electrons because we have 10 protons, no charge, and if we don't have a charge, do the opposite, add or subtract 0, we get 10. So these three 10s all come from different things, but they're all related to the fact that they have 10 protons. Well, now we actually need to draw a Bohr model of this. So the way I want to show this is by making an analogy to going to a concert. Let's say we are going to a concert and this is the stage. And here I am rapping on the mic. So let's put a little mic in my hand. And you're coming to a concert. Okay, let's say it's not me. Let's say it's your favorite artist, whoever that might be. Well, the theater, also known as the nucleus, this theater with the nucleus as the stage, this theater is a weird theater. It would have to in order to have me rapping on the mic, but it has 7 rows of seats. So we will draw 7 rows of seats, not proportional, by the way. These rows have 2, 8, 8, 18, 18, 32, and 32 seats. Well, I always make the analogy. If you go to a concert, it's your favorite artist, there are this many seats, and you're the first person in line, a normal, reasonable person is not going to walk into this theater being able to sit wherever they want and sit in the back row. If you're that person, I feel sorry for you, because if you're going to see your favorite artist, you don't want all these people sitting in front of you, especially when you're 5'4" like me. You're going to go sit in the first row. Well, this analogy is, this is the nucleus, these are the 7 rows of electrons. But we can only fit 2 electrons, or we can only fit 2, 8, 8, 18, 18, 32, 32 electrons in each row. So if you're the first 2 people to show up to this concert, or you're the first 2 electrons to go and fill in energy levels, you're going to fill in the first 2. Then the next 8 are going to fill in the second row. And we get 8 in the second row. Now for a total of 10. Then 8 in the next row. And so on until every one is full. That is the way electrons fill in the energy levels. So if we go back to this and we know we have 10 electrons, we know where the protons and neutrons are going to go. They are going to go on the stage. They're going to go in the nucleus. Well, if we have 10 electrons, we can't put 10 in the first row. We can't put 1 in the first row and 9 in the second row. We can put 2 in the first row and 8 in the second row. So, if you can't, you need to know these 7 numbers. You need to know that the energy levels for a Bohr model are 2, 8, 8, 18, 18, 32, 32. If you can't remember those 7 numbers in order, here is a little trick in order to figure that out. By the way, I didn't mention in the last video, but I really love this website. It's called ptable.com. We are just using the regular periodic table they have, but they also have these others that we will come to know a little bit. I want to point out this button right here. It's called wide. The periodic table, you may wonder why there are 2 rows down here. And why does the atomic number go 1, 2? It goes all the way through in order up to 56, but then 57 through 71 are down here. Then it jumps back up to 72 through 86, 87, 88, then 89 through 103 are down here, then it jumps back up. The reason is because these two rows fit in here. But if you actually include them where they are, which is why I want to go back to that button I was pointing out to you, let's push this button. It's called the wide button, and watch what happens. This is what the periodic table should really look like. And if we uncheck it, you can see those two rows called the lanthanoids and actinoids, they get removed and put down here. Well, the reason is, look at all the information we can see on this version. We can see the atomic number, the symbol, the name, and the average atomic mass. All of that info and these numbers, which we will come to know later, all of these numbers will fit in there. But when we go to the wide version, the only thing that we can fit in those boxes is the atomic number and the symbol. So the reason we don't show the periodic table in this form with the lanthanoids and actinoids included is we can't fit as much stuff in a box. But when we make it like this, now we can fit a lot more stuff in the into those boxes. So long story short, the reason we do this and cut those two rows out and put them at the bottom is so we can fit it on a piece of paper and get a lot more info in a box. So back to the wide version. If you can't remember 2, 8, 8, 18, 18, 32, 32, well, there are 7 rows on the periodic table. There are 2 in the first row, 8 in the second and third row, 18 in the fourth and fifth row, and 32 in the sixth and seventh rows. That is why we know these numbers. So 2, 8, 8, 18, 18, 32, 32. The number of electrons that can fit in an energy level is equal to the number of elements on that row of the periodic table. So let's go back and finish and actually draw our Bohr model for neon. What we do is you draw a circle. That enclosed circle is the nucleus. And we put the things that go in the nucleus in the nucleus. 10 protons, 10 neutrons. Now we draw an open circle, and I always leave the gap over here on the right. And then I ask 3 questions. Now, we've taken care of the protons and neutrons. Check, check. We now need to put 10 electrons in this picture. But we can only put 2, 8, 8, 18, 18, 32, 32 in each row. And we want to get to 10. So I always ask 3 questions. How many can I put in a row? How many should I put? And what does that bring our total to? Because we don't want to go higher than 10. We are going to put 2. How many can we put? 2. How many should we put? 2. Draw 2 dots. And it brings us to a total of 2. Okay, then we need another row. How many can we put in this row? 8. How many should we put? 8, bringing our total to 10. So draw 8 dots in here. Now, as we do these, I don't need you to write the dots every time, but just know that that's what this number means. So now we have 10 protons, 10 neutrons in the nucleus, and then energy levels of 2 and 8. That is a Bohr model for neon 20. I will give you worksheet number 1, and I would like you to do these after you watch the video. I would like you to do these so we can then cover them in class. So the worksheet number 1 is now officially homework. Any questions, please ask in class, and I will see you tomorrow.